Hello everyone, this is my first YouTube video, and in it I will show you how I designed and constructed a Tulipwood stave bowl, including making the necessary calculations to determine how much wood I need and what angles I needed to cut the staves. I will show you my method of cutting and gluing the staves, as well as how I added decorative rings and a base to complete the bowl prior to turning. The reason I have made this video is to share with you the methodology of stave bowl construction and the equations we have developed to make this easier. Here is an example of a completed 18 stave bowl made of cocobolo, maple burl, and African blackwood. This is a view of the bottom of the bowl. The sides have a slope of 50 degrees from the horizontal. The bowl is 280 millimeters or about 11 inches in diameter. I chose the rare and beautiful Brazilian tulip wood, a genuine rosewood, as the main constituent of the bowl. I had a number of highly figured turning squares that I had purchased over the years without a clear purpose in mind and decided to use them for this bowl. Most of them were 1.5 inches square, and since I wanted the grain to run radially away from the center, I cut them in pieces on the bandsaw to take advantage of its narrow kerf, then cut them to length, drum sanded them, and glued them together to make one long board. I cut 18 thin segments of African blackwood to serve as splines, or separators as I call them, between the 18 staves. Now we come to the technical stuff, wherein we discuss choosing the miter and blade angles for the saw, how to set up the saw, and how to use the equations for stave bowls. I swear this only takes a few minutes, and we only need to do this once, since I can refer to this section in future videos. So take a deep breath and we'll get through this quickly. I measured the length, width, and thickness of the boards to put into the equation to calculate the settings for my saw. Let me insert here that I and the other 3 guys that come to my shop have all converted to using metric measures. I'm not trying to make any political point here, it's just that I used the metric system during my professional career, and measuring things in millimeters is right in the wheelhouse of the lengths we use in the shop. Using the equations also seems more intuitive in the metric system. In any case, the next step is to cut the staves. For that you need to know the miter angle and the blade angle for the number of staves you want. There are several ways to obtain these angles. There are tables available online if you do a search for miter and blade angles for staves. There is software that you can purchase for constructing segmented bowls that also include angles for staves. And there is the excellent information in the back of Malcolm Tibbitt's book, The Art of Segmented Wood Turning, 2 pages of which are reproduced here, complete with my chicken scratching from over the years. In the red box are the number of staves. In the first vertical column is the angle of the bowl from the horizontal, and the next 2 columns are the miter and blade angles. Unfortunately, he doesn't have a column for 18 staves, so I had to use the formulas in the big red circle, more to come on this, which gave me the numbers in the small red circle in the upper right. As for cutting the staves, we use a compound miter saw with a high-end 80-tooth carbide crosscut blade. I know that many woodworkers cut their staves on their table saws, but my table saw was my father's and is over 50 years old. Many of the tolerances have gotten a bit shaky. So, since we have 2 miter saws in the shop, by common consent we dedicate one saw to making stave bowls of a certain configuration for a few months and then switched to a different configuration. I set the calculated miter and blade angles on the saw with the aid of a vernier protractor and cut the requisite number of staves from 1x6 pine. Then I tape the pieces together and test for fit. Usually I have to tweak the miter or blade angle very slightly and cut another set of test staves until I get a perfect bowl. Next comes setting the saw to cut the desired size of stave given the preset parameters. The variables I can still manipulate are the length and the thickness of the board, and one more thing. I can move the right-hand stop board on the saw to change the width of the stave as indicated by the red arrows. The stave is a complex polygon with several lengths that could be measured. We have tried to simplify this by concentrating on only one of these, the longest side on the largest end of the stave, which we call max L. This measurement is useful because it can be set by moving the stop on the miter saw, and this length is critical in the equations we have developed, and also because this length figures into the circumference and therefore the diameter of the bowl. Don't despair, all will be explained shortly. By the way, in the background is the subject of my next video, a maple, burl, and camotillo, or Mexican kingwood bowl that will feature gold leaf. What information can we collect that would have to be included in any calculations to cut the staves? These things would certainly be candidates. What are we trying to calculate? Given the specific situation, we either need to know the total board length or max L. I'll give examples of both situations shortly. First, let's assume you don't have access to tables or software to calculate the miter and blade angles, or you want to use non-standard settings such as 9 staves at a 43-degree slope for some reason. These two equations allow you to calculate the angles for any dimensions you choose. But what the heck is tangent to the -1? We'll tackle that in a minute. The bottom equation lets you calculate the saw kerf exactly if you are compulsive, but 3 millimeters or 1/8 of an inch is a reasonable approximation. These functions are designated arctan in trigonometry and are written in equations as tangent to the -1. So how do we calculate them? If you turn your iPhone, and I assume Android phones are similar, in the horizontal position while using the calculator app, several specialty functions appear. Of interest to us is the second button, as when that is pressed, an entirely different set of functions appear, including the tangent to the -1 or arctangent function. Now we have arrived at the heart of the matter and the impetus for creating this video. I was frequently faced with a situation where I had a limited amount of some precious wood and wanted to calculate how to make from it the largest possible stave bowl. I enlisted the help of my mathematician friend Raoul Burchette, and over several weeks of give and take, he came up with the following equations. They allow one to efficiently use the wood down to the last few millimeters, and I thought they needed to be shared with the woodworking community. First, let's suppose you want to construct a bowl with a diameter, before adding rings or other decorations, of 300 millimeters, about 12 inches, and you have plenty of wood. First, calculate max L by multiplying the desired diameter by pi, or 3.14, to obtain the circumference. Max L is then the diameter divided by the number of staves. I'll explain the other terms in the next equation. This second equation is by far the most frequent one we use, since we often find ourselves with that wonderful piece of wood of limited size and want to know how large of a bowl we can make out of it. This is exactly the circumstance with this tulipwood board. We can easily calculate the final diameter by knowing max L. Now it's just a matter of substituting the values for the measurements of the board. The miter angle for an 18 stave bowl at 50-degree slope is 7.11 degrees. The assumed saw kerf is 3 millimeters. The board thickness is 23 millimeters. The width is 133 millimeters. And the length is 700 millimeters. I also used the phone's calculator to determine the tangent of 7.11 degrees. After substituting all these numbers into the equation, just remember to make the calculations in the inmost parentheses first, and then proceed outward. Start with 23 times 1.19 and add that result to 133 and multiply that result by 0.125 and subtract 3. Then multiply all of that by 17 and add the result to 700 and divide by 18 to arrive at max L. This is the value I will set on the miter saw. To calculate the diameter, multiply max L by the number of staves, 18, and divide by pi to arrive at 315 millimeters, or about 12.5 inches. How do the blackwood separators figure into these calculations? They don't change max L. That is determined only by the measurements of the tulipwood board and the other preset parameters. What the separators do is change the final diameter. In this case, the 18 separators were each 4 millimeters thick, which would add 18 times 4, or 72 millimeters to the circumference. So the final circumference would be 55. That's max L times 18 is 990 plus 72 is 1062 divided by pi, 3.14, is 338 millimeters. The diameter has increased from 315 to 338 millimeters by adding the separators. After a final check of max L, it is on to cutting the beautiful tulipwood board. The bowl is laid out here with its 18 separators. The staves and the separators are ready to glue. The bowl is held together on the inside by duct tape and is propped against a sample bowl of scrap wood. There is a 14-inch band clamp ready to tighten around the base. It will be held up by thin strips of wood. I'm using regular Titebond 3 glue. I have done enough of these that I can slop enough glue on all of the staves and the separators before the glue sets up, but I would strongly recommend that you have someone else help you the first few times you try this, and even though I don't show it here, I wear plastic gloves. There is a notched board that goes on top of this assembly that is cranked down and tightened in place to force the staves together. This shows the disassembly of the ring press with the removal of the notched board. You can see that the ring clamp is held up in place by thin slats. Here is part of the taping on the inside of the bowl. With the tape removed, you can see that the glue joints are very tight. There might be better ways of flattening the top of the bowl, but I have not discovered them. I turn the bowl constantly on our belt sander until the top is sanded all the way out to the edge. The bottom of the bowl must be rendered parallel with the top, and we accomplish that with a drum sander. These surfaces must be flat and parallel to accept any decorative rings and the base. It's time to cut strips for the rings. It can be problematic drum sanding very oily woods like blackwood that tend to gum up and quickly ruin sanding belts. The trick is to keep the belt and the wood from overheating. This can be accomplished by running the belt at high speed, taking shallow cuts, and putting the boards through diagonally so that one place on the sanding belt is presented to the wood for a minimal time. I also put a less oily board at the end of a group as a chaser to help clean off the belt. You may also notice that I change the angle when I get through the entire set. This is our Wedgie Sled. I built the sled from plans I found online. The base is a 12-inch square piece of corian that I routed the slots and installed a single track on the bottom. We purchased several pre-cut wedges from Seg. We bought the digital gauge from Tom Lohman, but discovered the measuring block was too high for our sled. So we had to double stick tape 2 wooden slats on the sled to elevate our pieces of wood to the correct height. I'm too lazy to make another sled so far. Here we have set the sled for 72 segments for the top decorative ring, 36 tulipwood and 36 blackwood. These are the 36 pieces for the top ring. The only sanding that these require is to remove an occasional tab from the end of the segment. Gluing the 72 segment ring without assistance requires some forethought. The other guys are only in the shop 3 days a week, so sometimes I need to work alone. By setting the segments on their side, I can add glue to all of them just fast enough so that it does not set up and does not pool on the paper as it would if they were on their sides. I have them in this huge oval so they are far enough apart that I don't knock them over with my big hands until I'm ready to push them over all at once and push them together. When they all have glue, I tip them over, shove them together, and fasten a ring clamp around them. It's important to check the fit of each piece in this large ring and to measure the diameter in several places so it is perfectly circular. Press the pieces down to make sure the ring is flat. A 14-inch diameter ring with 72 pieces is unwieldy. I use my ring press to glue the rings in place. I always let the glue set up for a few minutes before clamping the slotted board down, as there is less tendency for the ring to drift. At this point, I also changed my plans for the bowl. I had 3 rings for the top, 2 blackwood rings, and the alternating tulip blackwood ring. However, for the bottom, the piece of tulip wood I had for the base was quite small. So instead of having 1 blackwood ring and 1 tulipwood blackwood ring above the base, I had to make 3 additional blackwood rings below the alternating ring to step down to the base. I had plenty of blackwood for the ring, so this was not a problem. Here I am cutting a waste block from maple to glue to the base. Drilling pilot holes for the screws for the waste block. Cutting the tulipwood base. gluing the base to the waste block with epoxy. The bowl is attached to our one-way stronghold chuck with the mega jumbo jaws, and the base assembly with the tulipwood and the additional 3 blackwood rings have just been glued together. Isn't that lathe pretty? We've had this Vic mark for less than a week, and we couldn't be more delighted. Looks pretty solid. All ready to turn. Please follow the link to part 2 of this video for the turning and finishing of this bowl. I guarantee there is not an equation in sight. Please subscribe by clicking on the button below. I will continue to post videos of bowl construction using the bowl from a board techniques, including more stave bowls, so-called bandsaw bowls, segmented bowls, and dizzy bowls. Thanks for watching.